So part 2 of my procedure is including sodium chloride, NaCl. I want to be able to classify this as a strong electrolyte, a weak electrolyte, or a non-electrolyte. My procedure tells me to get 1.00 grams. What I got was not exactly that. I got 1.09 grams. What I'm going to do is I'm going to transfer all of that solid sodium chloride into my volumetric flask. Here's my volumetric flask. There's the sodium chloride. The next thing that I'm going to do is I'm going to transfer deionized water, which I have right here, to fill my bulb about halfway. And the reason that I'm going to do that is because that makes it easy to swirl it and get this to go into solution. So I'm going to swirl, 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 as you can see. Okay. Now, one thing to keep straight here is that my solid, it appears, has gone into my solution. Might be tough to see. Okay. I see no solid in there. That means that that solid dissolved. Earlier, I used the term dissociate. Just because something dissolves does not mean that it dissociates. So dissolving is a question of, does it go into my solution to make a homogeneous solution? And dissociating is, does it actually break down or separate into individual ions? Okay, so I'm going to try to make as good a solution as possible. What's really tricky about using a volumetric flask is whenever you're adding water, okay, so I've got my water there and I need it to be right there. So what I'm going to do is I'm going to get some more deionized water. Now, to make this as precise as possible, I'm going to use my deionized water. I'm going to use this transfer pipette. And I'm going to transfer it like that. This transfer pipette here holds approximately 3 milliliters of solution, so it makes it a little bit easier to transfer a small volume. Oh, that's pretty much perfect. If you look there, well, your angle is a little bit off. It's coming from the bottom, but my meniscus is just below my line, so let's see if I can do it better. I think that's good. I'm happy with that. So what I have is approximately 1.09 grams, well, not approximately, I feel pretty confident about this, in 100 milliliters of deionized water. Okay, so now that I have this solution prepared, I'm going to transfer it all back to this small beaker. This is my experimental beaker. Whoa! Okay, so I've transferred all that volume. I was just getting a phone call, and my camera is also my phone and everything like that. So now what I want to do is I want to test and ask the question, does this solution, well, does it actually have strong electrolytes, weak electrolytes, or non-electrolytes in it? What I'm really asking is, does this solution conduct electricity? Will my lights light up? So the first thing that I want to do is get my solution connected to that terminal. Next up, go here and lo and behold, it's kind of tough to see, but they're lighting up. Fantastic. So that tells me that this solution right here, sodium chloride, is able to conduct electricity. Now the next part of this procedure is to transfer only 25 milliliters of it from here to my volumetric flask. I'm going to make what's known as a dilution. Okay, so I'm going to transfer 25 milliliters from here into my grad cylinder. Now from that grad cylinder, what I'm going to do is I'm going to pour it, remove some of these things, into my volumetric flask. Now this volumetric flask, it has 25 milliliters of a solution that previously had 1.09 grams of sodium chloride. So I've made a dilution, or I'm about to make a dilution, because I'm going to bring this volume all the way up to 100 milliliters.